A microcontroller is like a tiny computer on a single chip. It's actually a very small but powerful device. You can find these small brains inside many electronic gadgets we use every day. Think about your television remote control, or consider the microwave oven in your kitchen. Even a washing machine has one. These devices need a brain to control their actions, and the microcontroller is that brain. It follows instructions to make the device work correctly, and honestly, it makes our modern life much easier and more convenient. The 89C51 is a very popular type of microcontroller. It belongs to a family of microcontrollers called the 8051 family. Many students and engineers start their journey by learning about the 89C51, mainly because it is simple to understand. It is also very powerful for many small projects. Its design is a great example of how a computer works. Learning about it builds a strong foundation, and you can use this knowledge to understand more complex systems later on. It is a stepping stone into the big world of embedded systems. Imagine you want to build a small robot, and this robot needs to follow a line on the floor. The microcontroller is the perfect component for this task. It will be the robot's brain. You will write a program, which is just a set of instructions, and then you'll load this program into the microcontroller. The microcontroller will read sensors to see the line. Then it will control the motors to make the robot move. All of this control happens inside that one tiny chip. It really shows how a small device can perform a smart task. So, a microcontroller is not a big computer like a laptop. It is a dedicated computer designed for a specific job. It is small, cheap, and uses very little power. This is why it is perfect for embedding inside other products. The 89C51 microcontroller is a classic example of this technology. It has all the necessary parts of a computer packed into one small package. It is a complete system on a chip. Understanding this little chip opens the door to creating your own smart devices and inventions. The heart of the 89C51 is its central processing unit, or CPU. The CPU is the real brain of the microcontroller. It is the part that does all the thinking and calculating. It reads the instructions from your program, one by one, and then it performs the action for each instruction. For example, an instruction might tell the CPU to add 2 numbers. The CPU takes the numbers and performs the addition. It's the manager that directs all the activities happening inside the chip. Everything the 89C51 does is controlled by the CPU. Next, we have the memory. The 89C51 has 2 main types of memory. The first type is called ROM, which stands for read-only memory. This is where your program, the set of instructions, is permanently stored. Even if you turn the power off, the program stays in the ROM. The other type of memory is RAM, or random access memory. RAM is used for temporary storage. It holds data that the CPU is currently working on. For example, it might store the result of a calculation. Unlike ROM, RAM loses all its data when the power is turned off. The 89C51 needs a way to communicate with the outside world, and this is done using input-output ports, often called I/O ports. These ports are like the microcontroller's hands and ears. They are groups of pins on the chip, and you can connect wires to these pins. An input pin can read a signal from a sensor, like a switch, and an output pin can send a signal to control a device, like turning on an LED light. The 89C51 has 4 of these ports, giving it many connections for your projects. Finally, we have timers and counters. These are very special parts of the 89C51. A timer can be used to measure time, and you can program it to create a delay for a specific duration. For example, you can make an LED blink every 1 second. A counter can be used to count events happening outside the chip. For instance, it can count how many times a button is pressed. These timers and counters are very precise. They allow the microcontroller to perform tasks at the right time without the CPU having to constantly check the clock. All the components inside the 89C51 work together in a coordinated way. It's really like a well-organized team in an office. The CPU is the manager. It starts by fetching an instruction from the ROM, where the main program is stored. This instruction tells the CPU what to do next. For example, the instruction might be to read data from an external sensor. The CPU then knows it needs to interact with one of the I/O ports. This systematic fetching and executing of instructions happens very fast, honestly, millions of times per second. Let us imagine a simple task. You want to turn on a light when a button is pressed. First, you write a program for this and store it in the ROM. The program tells the CPU to constantly check the state of a specific pin on an I/O port. This pin is connected to the button. The The CPU uses the I/O port as its input channel. It keeps asking the port, "Is the button pressed yet?" The port checks the electrical signal from the button and reports back to the CPU. This continuous checking is called polling. When you finally press the button, the signal on the pin changes. The I/O port tells the CPU about this change. The CPU, following the next instruction in your program from ROM, now knows it must act. The program says that the next step is to turn on a light. The light is connected to a different pin on another I/O port. So the CPU sends a command to that I/O port. It tells the port to send an electrical signal out through the pin connected to the light. This signal provides power, and the light turns on. During this process, the CPU might need to use RAM. For instance, it might need to count how many times the button has been pressed. It would store this count number in a temporary location in RAM. If the task involved timing, like keeping the light on for exactly 5 seconds, the CPU would use a timer. It would start the timer and then wait for the timer to signal that 5 seconds have passed. Once the signal comes, the CPU would then send another command to the I/O port to turn the light off. All these parts work together seamlessly under the CPU's control. The 89C51 microcontroller is incredibly versatile. You can find it working quietly in many devices. A simple example is a digital thermometer. The microcontroller reads the temperature from a sensor, then processes this information, and finally it displays the temperature numbers on a small LCD screen. Another common use is in a security system. The 89C51 can monitor sensors on doors and windows. If a sensor is triggered, the microcontroller can sound an alarm. It is the core component that makes the system intelligent. Think about more examples around your home. A microwave oven uses a microcontroller to read the keypad, control the cooking time and power level, and display the remaining time. In a television, a microcontroller listens for signals from the remote control and then changes the channel or adjusts the volume accordingly. Even simple electronic toys often have an 89C51 or a similar chip inside. It controls the toy's sounds, lights, and movements, bringing it to life based on the program stored within its memory. These are all tasks that require simple but reliable control. Learning about the 89C51 microcontroller is very important. It teaches you the basic principles of how computers work. You learn about hardware and software, and you see how they must work together to create a useful product. This knowledge is not just for electrical engineers or computer scientists. It's useful for anyone interested in technology and making things. It gives you the power to create your own electronic projects. You can build automated systems for your home, create custom gadgets, or even start a career in the exciting field of embedded systems. In summary, the 89C51 is more than just an old piece of silicon. It is a gateway to understanding the digital world. By studying its simple architecture, the CPU, memory ports, and timers, you learn fundamental concepts that apply to all modern electronics. The ability to program a small chip to interact with the physical world is a powerful skill. It empowers you to move from being just a user of technology to becoming a creator of it. This journey begins with understanding the magic inside a single, humble microcontroller like the 89C51.